All right, so you've spent a lot of time in the world of traditional databases. Well, today, we're going to look at what's next. We're diving into the really diverse and exciting world of NoSQL databases. Look, you've got the whole rows and tables thing down pat. You're a pro. But let's be honest, data is getting bigger and weirder, and sometimes it just doesn't want to fit into those neat relational boxes. So, what do you do then? Let's find out. Okay, let's kick things off with the absolute simplest place to start in the whole NoSQL universe. It's kind of the OG, the foundation for a lot of what comes next. I'm talking about key value stores. So think about it this way. What if you don't need all the complex queries and joins? What if all you really need is to look something up super fast? You know, a simple, direct, blazing fast lookup. Kind of like grabbing a dictionary to find one word and its definition. Simple, right? Well, that's exactly what a key value store is. At its heart, it's just a big collection of pairs. You've got a key and you've got a value. That's it. It's probably the most straightforward type of NoSQL database out there, and it's built for one thing really: speed. I mean, look how simple this is. You've got your unique key, and it points to a value. Done. It's this beautiful simplicity that makes it perfect for things like caching or storing user profiles. Anytime you just need to grab one piece of information quickly. You'll see this in action with systems like DynamoDB or React. But, you know, life isn't always that simple, and neither is data. So let's switch gears and look at things from a totally different angle. Our next stop, column stores. So this raises a really good question. What if your data is more complex than just a single value? And this is the big one. What if it actually makes more sense to group your data by columns instead of by rows? You know, the complete opposite of how you're used to thinking. And that is precisely where column stores come in. They literally flip the script. Instead of organizing everything into rows, they organize it into columns. Now, why would you do that? Well, for analytics on huge data sets, it is a total game changer. You only read the columns you actually need, so you're not sifting through tons of data you don't care about, which makes things crazy fast. Yeah, it's a totally different way of thinking. Forget grabbing whole rows. Here, you're grabbing just the columns that matter. This is the kind of tech that powers absolute giants, like hbase and Google's Bigtable. All right, so let's circle back to that simple key value idea for a second. What if we could take that concept and, well, make it a lot richer? That brings us to our third type, document stores. Okay, so we love the key value idea for its simplicity, right? But what happens when the value part needs to be more than just a single number or a piece of text? What if the value itself is, well, a whole document with its own structure inside? And that is the key idea here. Document stores basically take that key value concept and put it on steroids. They're a direct evolution, just way more flexible. Let's break that down. In a simple key value store, your key points to, say, a name. Simple. But in a document store, that same key points to a whole structured thing. Think of a JSON file. It's a self-contained package with all its own fields and data inside. It's a huge difference. The big takeaway here is that every single record is its own complete, flexible document that you can grab with its key. This is amazing for complex data because you don't have to define a strict schema ahead of time. You've probably heard of the big players here, like MongoDB and CouchDB. Okay, for our last category, we're going to take a pretty big leap. We're going to shift our focus from storing the data itself to storing the relationships between the data. This is where things get really interesting. Welcome to graph databases. So, up until now, we've been storing things, items, data points. But what if the most important thing isn't the what, but the how it's connected? What if the real gold is hidden in the relationships? That is the exact problem that graph databases were born to solve. They're built on a cool piece of math called graph theory, and their entire purpose is to map out and navigate those complex relationships, and to do it super fast. It's actually pretty simple when you break it down into its three core parts. First, you have your things, or entities. Those are called nodes. Then you have the lines connecting them, the relationships. Those are edges. And finally, you have details about the nodes and edges. Those are properties. It's a really natural way to draw a picture of how things are connected. This is why it's absolutely perfect for stuff like social networks, who's friends with whom, or recommendation engines. People who bought this also bought that. Anytime the connections are the most important part of the story, this is where you turn. Neo4j is a really big name in this area. Phew! Okay, we've gone from super simple pairs all the way to these complex webs of relationships. So let's wrap this up and get to the big question. How on earth do you choose which one is right for you? Here's the cheat sheet. Need lightning-fast simple lookups? Key value. Analyzing huge amounts of data? Column store. Dealing with messy, flexible data? Document store. And if it's all about the connections, that's a job for a graph database. And that really brings us to the most important point of all. It's not about asking, hey, which database is the best one? The real question is, which of these models is the best fit for my data and for the specific problem I'm trying to solve? Nailing the answer to that question, that's how you really unlock what NoSQL can do. Hey, if this breakdown helped clear things up for you, do me a favor and hit that like button, share it, and subscribe so you don't miss the next one. Thanks for watching.